All right, we're on lesson 51. As we start this new unit, the book has decided to review something they taught you 2 lessons ago. But okay, let's take it. Let's make sure we master this concept, and then we don't have to worry about it anytime whenever it pops up. We're looking at scientific notation of large numbers. So what does it mean to take on a big number? So let's go ahead and read our problem and get right to it. It says write 8.4 times 10 to the 11th power in scientific notation. So basically we just got to break this down. 8.4 times 10 to the 11th. Yep, that's literally what you have to do. I'm not kidding. Breaking it down. All right, moving on. Okay, now let's take a number that we've broken into scientific notation and turn it back into standard form, right? Standard form means let's throw all the digits up there. All right, so we got 2.37 times 10 to the 9th. We remember that when we multiply, we're moving the decimal to the right, and because our exponent says 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our decimal would be right there. We throw in some zeros now. 1. So we got our zeros in there. Some of them have some curly hair, some of them have no hair. And if we want to make it nice and neat, we come back 1, 2, 3, 4, 5, 6. There ends up being 7 zeros. And we come back this way and throw our place values in there. So we get thousands, right? Thousands, millions, billions, 2 billion. Wow. All right, working through it. Okay, let's start with a number and go the opposite direction. Okay, for writing scientific notation, we're going to start with the digits that have significance, right? The zeros don't have significance. They're going to be covered by the power of 10. But here, what we're going to do, scientific notation only has one number as a whole number, right? So we have our first number, our first digit, this one right here, is going to be our whole number. So that's our 4. And then we're going to put a decimal point there. And then we're going to put the rest of the significant digits that are necessary. And so we have our decimal now that we're going to work with. And now we're going to multiply by a power of 10. Now remember that this power of 10 happens to do with the number of place values that we had to move the decimal. Now technically the decimal is right here. So let's count them, right? 1, 2, 3, 4, 5. And this is where you're going to want to stop. But remember, the decimal isn't there, right? It's between the 4 and the 3. So let's start over. 1, 2, 3, 4, 5, 6, 7. We actually had to move it 7 places to get the decimal, so that the decimal is right there. So we can't forget those decimal places when moving it over. Whether it's 2, 1, 3, 4, 5, 7, don't forget those decimal places. All right? And so in the end, we come up with an answer of 4.37 times 10 to the 7th. All right, now that we have this understanding of what it is, once you take your understanding of numbers, powers of 10, scientific notation, and solve these 2 sample problems. Compare them and tell me which one is bigger, greater than, less than, or if they happen to be equal, write equal. All right, that's our lesson 51. Enjoy.